Welcome to webinar about D1 physical card. We hope it will be informative, and it will cover all the necessary aspects, so you could start your development and integrate the D1 SDK. Physical card introduction. Our D1 physical card service provides multiple features to issue a physical card, often known as the plastic card, together with control over management functions once it has been created. For the issuing side, you can trigger the production of a physical card through us, as well as track the current production status. For the control part, you can manage activation of the physical card, the display of its associated PIN, as well as changing the PIN directly. D1 card issuance. Physical card ordering flow. In this slide you can observe all the individual steps the creation of a new physical card undergoes. It starts with the creation of a new card on the issuer side card management system. Next, the card production is requested towards D1. Important parameters such as card data are set, and due to its physical nature, delivery information and packaging are also required to be selected. Our D1 solution will store this card production request and prepare the production data. Lastly, the card creation request is sent to one of our local personalization centers around the world. We have multiple regions: Europe, Middle East and Africa, Latin America, North America and Asia. Physical card ordering parameters. The call to D1 to produce a card allows various back-end configurations before fulfillment. First, you choose the card product, which has different profiles and personalization options. This includes a set of EMV parameters according to industry standards. Next, you will provide sensitive data such as cardholder data, MAG data or PIN. Finally, packaging, delivery and issuance forms need to be submitted. During issuance, there are different priority levels by which lead times and cutoff times are specified. The same is true for delivery. Different carriers will ship the product, according to their own priority schedules in varying time frames. Lastly, the delivery type can be to the cardholder's home address or in bulk to a delivery point. Please refer to your developer documentation for up-to-date estimations and options for these parameters. Card production notification. This diagram shows real-time notifications about the card production and delivery status sent to the issuer. A notification is sent to issuer backend when the data preparation is finished. The card production starts. The card has been shipped. During the shipment, optional. When an error has occurred. Please note this flow is available for any card in production requested by API or by file. D1 card control. Activate card. In this slide we are showing a visual example of how a flow to activate the physical card could look. The end user would be seeing a button to activate their physical card in the issuer app. Upon clicking that button, a new screen appears which asks for the last 4 digits of the primary account number, short PAN number, embossed on the plastic card. Alternatively to the PAN, the card security code, short CVV2, can be used as the challenge for card activation. In the next slide we will go into the details of this card activation flow. Looking at the details of the card activation flow, first, the end user must initiate the request. The SDK then will challenge him with the activation method by either PAN or CVV for his possession of the actual physical card. Next, the SDK will call the D1 backend to verify this challenge. For the last 4 digits of the PAN, this verification will happen directly on D1 backend. However, for CVV, another request to the issuer needs to be made, as it is sensitive data and therefore not stored on D1 backend. Once the challenge has been verified, the request for activation is sent to the issuer. On successful activation of the card, the SDK then will return in the callback on success that everything has gone well. Display PIN. This section shows the user experience how to display the PIN of the physical card. First, the end user requests to reveal the PIN via pressing a button. Due to the sensitive nature of this request, he is then asked to authenticate once again. Lastly, the PIN is displayed for a limited time duration. In the next slide we will explain in detail the prerequisites and standards required for this feature. As before, you can see the flow starts with requesting the PIN by the user interacting with the Issuer app. The Issuer app will then request the display of the PIN from the SDK. Due to the sensitive nature of this operation, it is important the login API has been called within the previous 5 minutes. The SDK will then forward this request to the D1 backend, which will contact the Issuer backend as the PIN is not stored in D1. It is expected the PIN has the format 3DES ISO 0. Next, the D1 backend transciphers to the device key and supplies it to the SDK. As prerequisite for this, a PIN encryption key, PEK, identified by the KID, has to be exchanged with Issuer and stored in D1, to allow the transciphering to the device key. Lastly, the D1 SDK reveals the PIN in the card PIN UI. Change PIN. As you can see, this function is very similar to displaying the PIN. The end user selects a button to change the PIN. He gets prompted to authenticate himself. Next, a screen is displayed where he can enter and confirm a new PIN. And finally, confirmation of the new PIN being active is shown. In the next slide we will explain the details of this flow and technical requirements. As before with showing the PIN, this operation is considered sensitive and therefore the login API will have to be called within the previous 5 minutes. To enable PIN change via the D1 SDK, various prerequisites are required depending on the supported PIN format supported by the Issuer. In many ways, the SDK only acts as an input collection point, whereas the actual PIN change happens on the Issuer via the D1 backend. PIN formats currently supported are PIN ISO 0 or PIN 3DES SECOS. For PIN ISO 0, the PIN encryption key, PEK, identified by the KID, has to be exchanged with Issuer and imported in D1, to allow the transciphering to the device key. For PIN 3DES SECOS, the PIN reference value key, identified by the PRWKID, and the MAC key, identified by MACKID, have to be exchanged with the Issuer and stored in D1, to enable the computations. To understand the full flow of this operation in further detail, please visit our developer documentation. Next steps. Thank you very much for attending this D1 SDK physical card webinar. We hope we answered most of your questions, and you found this information helpful. We encourage you to go through our developer portal pages to understand the solution in more detail. The next phases on your D1 solution integration project should be discovery, onboarding, integration, testing, and then launch. Thanks for selecting us as your service provider.